Okay, we're back again. I think this is going. Alright, I don't know how well this is going to go. I got the feeling I'm just going to forget something. But anyway, just double check over everything. Alright, yes. So, today we're going to continue with my series about ICs, but we're going to stick with this one, which I called the 4049. So this is a CMOS 4049. And we're going to make an interesting little circuit. I tried to find if anyone had done this before and put it on the internet, but I couldn't find it for this particular IC. Like, this is a very common thing to make, but not with this particular IC. So I'm hoping that will make this video at least kind of interesting. But what we're going to make is a thing called a flip-flop. In particular, they're called an SR latch. I think that's the term. So it's a set and reset latch. So we'll just turn it on and we'll see what it does, and hopefully it still works. So we turn it on and the light comes on, but we press one of the buttons, this one here, it turns the light off. So I pressed a button, so this is kind of like a switch. So this might seem really stupid at first, because you might be like, well, why don't I just have a switch that goes backwards and forwards? But we're doing it with buttons, and this has lots of advantages, because something else might be, instead of doing buttons, you might have something else sending electrical signals to turn things on. So the interesting thing about this circuit is that it can change state. It can be in two different states, one with the light on and one with the light off. So if I press that, it turns it off. This is the off button, and this will be the on button. So if I press that, it turns it on, and I can keep pressing it, nothing changes. And then I can press that one and it turns it off. So on, off. So one of them is the set button and one of them is the reset button. So both of these are connected to the high voltage or the 5-volt line. So they're both sending 5 volts into this chip, but one will make it turn off and one will make it turn on. So how does this work? And what are the pitfalls in trying to make this work? So to make this work, and I probably should have brought along my little book. One thing I forgot is to show you the traditional way of doing this, and that usually uses the chip called a 4011, or a similar chip, which uses a NAND gate and does this kind of strange little thing. And this one is not going to do that. So it's going to do it in a slightly different way, but it actually turns out to be essentially the same way. You just have to pay a little bit of close attention. So we might do a video, when we do stuff about the 4011, then we'll find out how you do it with the 4011 and compare and contrast with this model here. We're going to rebuild this tonight, so I've got all the parts to rebuild it, and we'll go through step by step. But anyway, we're going to start off and we're going to create a so remembering what a 4049 is, it's a hex inverter. So I'm going to get my little book out and I'm going to find the page, turn it upside down. It's a hex inverting buffer and TTL driver. Forget that part. All I care about is it's a hex inverter. And that just basically means, as I said before, so that little triangle with a little dot on the end, the dot means inverting. Means basically, so that's kind of like I don't know what those are. Well, anyway. Point is, the signal that goes in here, so we're going to start talking about signal. So a signal can be a high voltage or a low voltage, and when the signal goes in here, it comes out the opposite way around. So if it goes into like this pin here, it will go through and come out the opposite. If it's a high voltage, it will be at low voltage. So if there's a high voltage on pin 9, there will be a low voltage on pin 10. And if there's a low voltage on pin 9, there will be a high voltage on pin 10. And this works for all of these. These are all the same, and they're all independent, and there's 6 of them, and that's where the word hex comes from. So there's 6 separate inverters in one little package. So I've actually, in this model here, used 3 of these. So this one uses 3 of these to make this thing. But we're going to start with this. We're going to start with this very strange little circuit, which doesn't seem to do anything. So one thing to remember about the ICs is that there's a separate power line, input. So this is the high voltage input here, and this is the low voltage over here, the ground. So there is some actual connection to the battery or the power source in here. But for now, we're just going to look at what happens if you connect like pin 10 in this case to pin 11, and then pin 12 back to pin 9. Which seems like we can kind of forget the bottom bit. I think I was actually going to start by forgetting the bottom bit. We'll just put this over the thing. forget the bottom bit for a second. How much time have we got? Oh, lots, cool. So if we get the bottom bit, so let's just say this over here was a high voltage, then it will go through here and it will be a low voltage signal over here, and then it will go into here, and then it will come out, and then it will be a high voltage. So this bit here essentially it seems to do nothing, though it does buffer the signal. We can talk about that later on. And that's one use of it, of this kind of circuit, is if you put two of them together, you create a buffer. So what's kind of happening over here won't affect so much what's happening over here. They're kind of kept separate. But you might think, other than that, it's kind of pointless, especially if you put them back together, if you tie them back together. So putting this over there. So the output of here is going back and coming into here. But then remember, the output, if this was high, this will be low, this will be high, so it will come back in and nothing, and it will be high, which is what we had in the beginning. So we're just saying that somehow magically this is high. Now if this was low, this would be high, and this would be low, back again, and it's that sort of way there. So the problem is, if you made this circuit, you don't really know. It's kind of like some weird quantum physics experiment, because you don't really know what the state is. You just know that whatever goes in here will be inverted and will come out here and the opposite way around. I just keep coming around. It will be a stable situation, because this is the same as the start is the same as the end, or the beginning is the same as the end. You might actually think, you might jump ahead and you might think, well, what happens if I actually just had one of these and I connected it to each other? Because it would go positive, it would be like high voltage low voltage goes in, and that would be low voltage, that would be a high voltage. And that's how you make oscillators. Well, part of how you can make an oscillator. And we'll talk about that. An oscillator is just something that changes between two states over and over again. We're going to do that in another video, but today we're doing this. But the thing is, well, what if you could attach something over here? So how do we adapt this to make this into a set and reset latch? Well, here's a basic idea of what you could do. We can change our circuit to look like this. So now we have these little lines that go in. They aren't always connected. So there's a button in this case here, button here, and button here. So we're going to do today, we're just buttons. And then we may talk about how we could do this when you have a different kind of thing, like a signal that could either be a high or a low voltage. So at the moment it's either a high voltage or it's not connected at all. And this matters a lot for all these things. But for here, let's just say what we can do. So here's the output. So instead of just going down to here, it's also going this way and is going into a LED via a resistor down to ground. So if this was a high voltage, that would go through here and turn the LED on. And if this was a low voltage, that would go through there and turn the LED, and the LED would be off. It wouldn't be glowing. And how we could change, so that's how we're reading the current state of this system. And how do we change the current state of this system? Well, if we apply a 5 volts here, in theory, this is not going to be the final circuit, because this won't work necessarily the way you want it to. It does kind of work for certain situations, but not in general. And it's not what I've done in my circuit. But anyway, if we were to push the button and put 5 volts here, then whatever this was, we're basically trying to force this up to 5 volts. So then we're turning that to 5 volts inwards, and then it will come out as being low voltage. So this will be turned off. So if you apply 5 volts here, the idea is the light will go out. So this will turn the LED out, and so now it's low voltage goes in there, low voltage goes in here, and then you know it's high voltage here, and so it doesn't really matter anymore that this is high voltage. So it just needs one little push, and suddenly the system changes to to that state where this will be off. But if you would put 5 volts over here, the opposite would happen. So if say currently we're in a state where this is a low voltage going around here, and we put in a higher voltage, and then this pushes this, and this changes this one to a low voltage, and then that one to a high voltage, then we get back into that stable system where it's high, low, high, and the output will be high, and we'll have an LED on. So this is the kind of theory, but we have to play nice with how the IC actually works, and what's going on inside the electronics in it, and that kind of thing. So, well, we'll try and build this and we'll see what happens. Maybe we'll start with this. So this is where I was kind of like getting a bit lost. So we better just check out what the word CMOS, it means complementary metal oxide semiconductors or something, so that we know what it is. Here we go. Complementary metal oxide silicone. That's what it means. Alright, so if you hear the word CMOS, it means that. They have some kind of cool quirks, and they can do some neat things. So another one that you might hear is TTL, and we're not looking at TTL today, so it will work differently, and this circuit might not work if you had an inverter with a TTL circuit. But let's go and bring out our little friends, these things, which has already got a wire on it, and put that one there. And we're going to bring out a brand new, so I'm going to put these two together the same way I did before. So they actually slot together like Lego, kind of like Lego. And where's my two little buttons? So we're going to put my two little buttons, I'm going to put my buttons up here so I can see them the way that I want. So these are different style buttons to what I just used, but that's alright. I had a big bag of the little small ones. I like the small ones, but they disappeared. Alright, and then we'll put that on there. So this little guy is going to go, it's got to be the right way around. So it's going to go over here, and it's going to provide my power to everything. And over here we have a delicate thing. So the first thing about CMOS, it's quite delicate and you can break it by touching it, because it's sensitive to static electricity. So sometimes you have to bend the legs. I think we did this last time. Bending the legs down and plonk that in. Let's just move it along a bit into there, and we're going to need my book to keep dropping, and we need a pile of wires, which of course I have moved so that I don't know where they are. Maybe we'll just have to use, no, those are the wrong ones. Oh my goodness, oh, that's right over here. Just relax, it's fine. Alright, and we have, I'm going to use, in this case here I used a different kind of resistor, but we're going to use this one. I think that's the right one. That's a 330 ohm. And we're going to perhaps try one of these, and we're going to need the higher ones. Well, let's get going. So the first thing we want to do, going back to my picture, which page is it on? This one here. So I don't know if you can see that, but just have a good look at that. So I'm going to read it for a second. Now, the first thing with CMOS, and this is important, is that the inputs, the things that you aren't using. So if you look at this circuit here, I've got these little purple wires over here. These are just basically connecting the inputs that I don't use. So I'm not using half of these. So I'm just connecting the inputs to some value, to ground. So these are all connected to ground. Because apparently the neat thing with CMOS, why is this sitting there? Apparently the neat thing with CMOS is that they don't really use a lot of power unless they're changing state. So unless they're doing something. So when you're switching and you're applying different voltages, that's when you're actually using more power. And so you'll probably, if you aren't tying anything to anything in particular, it will, in fact, it might actually fluctuate a bit, and that's what's going to cause it to use up more power. So let's look at the thing. We're going to need a small one. So we're going to start by doing this link here. And looking at this one, this is like, hold on, I'm going to turn this one around. And I broke it. Okay, I do have a thing for taking these out. So, in general, don't take them out like that. Please don't break. It's okay, I've got a lot of these. That's not very professional. Okay, next time just use the pliers to take them out. Alright. So the only reason I'm turning it around is then it matches the picture in the book. This is going to take me longer than 30 minutes, isn't it? Oh, did I break a thing? No, I didn't. Okay, it's all fine. It's all good. Just relax. We've got 14 minutes to go. And this, of course, is going to take way too long. Alright, so we'll just do it on this side here. So, first off, we'll set up the power. So, the pin number 1, which is the one that's over here. So, there's a little circle, remember, in here, and it matches up with the picture over here. Not a semicircle, and that says pin 1 goes to the power. So, I'm going to put that green one there, which is like the worst color to use for that. Because green's normally like the lower voltage one, but hey, we just have to get this done, and we're going to use another green one. We're going to be even worse. That one is actually going to go to ground, and that's the other one. So in you go. Oh, I've ruined this. It really is still too hot for this. I should just save all this for winter. So just going over this, the power rails, that one goes, so pin number 1, which is the one next to the circle on the left hand side, goes to the high voltage, and the one at the bottom, which is pin number 8, going down the side, so 1, 2, 3, 4, 5, 6, 7, 8, this goes to the ground. So in this case it's going to the blue line. So now it's all powered up and ready to go, but we still need to add the rest of the things in. And I got the feeling I'm going to run out of short wires. So we're going to kind of use these ones, which aren't quite short. So it's going to look like a mess. Alright, oh wait, we've got this one here. We've got these ones. Okay, so pin 2 and 3. So pin 2, pin 3, sorry, goes in here, comes out of 2. And pin 5, which is a bit further along, goes in as an inverted and comes out at pin 4. So I'm going to take the output of pin 4 and I'm going to connect it to pin 3 by doing that. So pin 3 to pin 4 to pin 3. So basically this bit here, pin 4 is coming out and it's going to go into pin 3. And that's going to be this part of the circuit here. And then I'm going to connect up. So the output of pin 2 then has to go back around into pin 5. So 2, 3, 4, 5. So it's going to look a bit messy. I think that's probably too long a wire. So I'm going to make it look terrible by bending it. And it's going to go over the top. I always feel funny about wires that go over each other. Oh, not the thing. Sorry. Oh my goodness, take the book away. Oh, worst videos ever. Well, I think it makes it more educational if you do it this way, because then you feel like you're not such a you're not so bad at it yourself, because that's probably close enough. Like, it's a bit hard to tell if it's working or not, of course. So if I turn it on, nothing happens because I can't see anything. But in theory, I've created my first circuit, which I've lost because it's not actually on my lap. It's right here. So we've created we've created this circuit. So let's just add in our LED, and we're going to use the long wires for this. Except, where's my supply of long wires gone? Where are my little, here we go. I think this is all that I have left. All these little plastic things from Lego sets. This guy is going to come out of, so, alright, so I'm going to say that the output, so just to go over what I just did, pin 3 and 4 are connected, and pin 2 is going around to pin 5. So I'm going to take, so it's actually going this direction. So the output, according to my picture, is going to come from pin number 2. So I'm just going to put another little wire onto pin 2, and then I'm going to take it over to here. Alright, so it's jumping over here. This is a white wire, probably not the best choice. And I'm going to stick in, I feel like I should just stick with what I did before, in case it actually works when it's not supposed to. I'm going to put this one, actually I'm going to cheat. Where's my little LED collection? Oh, here's a blue LED. Maybe I shouldn't use a blue LED either. This is really mucking everything up. Let's just use the same kind of style of LED. These are all the big ones. Stick. This is totally unprofessional. Where is that big box of LEDs? It's on my desk all the time. I have all these things that I just don't need. Oh, all I want is one little yellow LED. Oh, I don't know where I put them. So we'll just use these little dinky green ones, because they're pretty neat. Alright. So dinky little LED, it's going to go there. And I'm going to take my smaller, because I know these are actually 330 ohms. And then I'm going to connect that. So I've gone and done it slightly different to the picture. Oh, and it comes on, kind of. Alright, well that probably will do that. Alright, so I've got my high voltage coming out here, and it's going into here, and the LED comes on. So in fact, I've done it the other way around. The LED is going first and the resistor is going second, because the resistor is just, so I'm using that as a wire. But that's okay, you can do it whatever way. I'm just doing that because it takes up less space. But we can cheat now. Let's just actually, because we're going to jump ahead. Or actually, no, let's actually, okay, if we're going to use another board, the first thing is we have to connect up the power rails, because this doesn't have any power on it, because these rails aren't connected to anything. So I'm just going to jump these across and brake, because these are so bad. I hate these things. Oh, that I'm sure they just get worse every time I use them. Okay, and so that one goes there. If you're actually patient and look after things, they work fine. Alright, so now this little button, I'm going to run out of wires, aren't I? I really am running out of wires. I'm going to put that one. I think this will work. And so I want this to go, I'm just going to guess, it's going to go into that one. And the other one is going to go into here. This is so confusing to see when you watch this. So I'm basically just connecting up the buttons to here, but the buttons aren't connected to anything yet. Oh, it's gone and turned itself off. So that was kind of neat. You might actually be able to get it if you touch things. Of course, the light could have gone off because I broke something. It could have just blown up. So we'll just use two purple ones to connect the buttons to the high, oh well, we could just do it this way, couldn't we? Yeah, we could. We could just jump straight across. So we'll do that. So that one's going to jump straight across. So, oh my gosh. Maybe that was a bad idea with those ones. This is not long enough. This one, on the other hand, look at this. This was just made for this. I don't think we're not going to get round to the, because it's not supposed to work. What if it did work? What if this was fine and the way that it was? Because I can't handle that. It's not supposed to work. The whole point of this is that this part doesn't work, and we're going to have to go through and talk about how CMOS things work. Alright, so this button is now connected to the, so I don't even need these wires, because I'm not actually, you can take those off because they're confusing. So this one is going from 5 volts into here. So the 5 volts is coming from this breadboard, going across here. What time do we have? 4 minutes. Going into here, and then I'm connecting it up to here, and it's doing just as this little picture says. This 5 volts is going to go into this one, and that 5 volts is going to go into there. I don't know if that's exactly the correct ones, but we'll see. I just have to make sure that's actually 100% correct. This is a look at the picture. So I want to go into 3. 4 goes into 3. So this one here is this button here, and that one here is that one there. So let's just try it. kind of goes on and it goes off. It goes on. So it does kind of work, but you can see it's a little bit strange because the light comes on, the light goes off. What I wanted it not to work. I have to say I'm a little bit put out that the whole thing's actually worked in the first place. But there's a reason for that, and we're going to have to talk about this. I've just got to find if I have any more 100. Here we go. So I'm going to change this. So I'm going to use my trusty giant out of place looking giant high wattage resistor that's very big and bulky, but it's very easy to see and very easy to put in. I'm going to take that one out and I'm going to replace it with a 100 ohms. It's got a lot of sticky stuff on it. A 100 ohm. So we've gone from 300 ohms and we're going to replace it straight with, alright, and now it works the way that it didn't work before. So that's good. So it does work with 330 ohms, but it doesn't work in this case. And that's to be expected, and we're going to go through why, because that will help us understand how CMOS chips work and some of the pitfalls, but I think it's going to be the next video. But now if I press the button, the light does come on, and I'll explain why that is, but you can kind of see why it is. If I was to actually put 5 volts in here, well, that 5 volts is not just going to go into here, it's also going to go all the way around here, out through here, and into the LED. So no matter what, even if this part, even if the actual IC completely failed, pressing this button while holding it down, the light will come on. And you can see this when I press the button, the light comes on. And if you remember before when I had the 330 ohms, when I pressed the button, the LED was brighter, than when I took it off. Even when it turned itself on, it was dimmer without me pressing the button. Whereas in my original, it's very consistent. You turn it on, the light comes on, and it stays on, and it isn't different brightness. And if I hold the button down, it's the same brightness as when I take the button off, the finger off the button. But nothing happens like this. It doesn't stay on, it goes off straight away. So there is a problem. So just before I finish, we'll just go back to the 300, I think it's the 330 ohm resistor. So this is actually important. So you can see what I mean. When I press the button, it's brighter. It's a bit hard to see because it's hidden away. Sorry. We'll come up real close. It's not the best one to use, is it? Should have got better lights. Where was that little blue one I had? Well, here's a red one. I could have used this one. So we're going to replace this one with a red LED. Everyone loves the red ones. Like, I go crazy for the red ones. Alright. So is that easier to see? That when I press it, it's brighter than when I don't press it. And this does work, but it doesn't work quite as well as I want it to. And there are little faults with this. And they're bad faults. And also it might be bad if I press both buttons at the same time. But it seems fine. So anyway, we'll finish it there because we're running out of time, and we're going to come back and do yet another 30-minute video about the next step, about making this actually a better product. So right now, this kind of works, but it's wrong and needs a lot of work. So thanks for watching, like, share, and subscribe, and please come back and watch the next 30 minutes of me mucking everything up. Bye!